Today you are going to learn 10th class 8th chapter, that is similar triangles, in that exercise number 8.4. In this 8.4 mainly we discuss about the Pythagoras theorem, and the related to the Pythagoras theorem there will be two more theorems. Let us discuss about those theorems here. Based on these theorems, the complete exercise number 8.4 is depends. So here theorem number 8.4 is that if a perpendicular is drawn from the vertex of a right triangle to the hypotenuse, then the triangle on both the sides, the perpendicular, are similar to the whole triangle and to each other. What is the meaning of it? Simple. See that here ABC is a right angled triangle. Where is the right angle here? The right angle is located at B. Here triangle ABC is a right angled triangle. Right angled triangle. Where right angle is located, angle ABC is nothing but angle B, that is equal to 90 degrees. So angle B equal to 90 degrees. So here what we have done, we have drawn a perpendicular from the vertex of right angle to the right triangle on the hypotenuse. The perpendicular we have drawn from the 90 degrees to hypotenuse. So this perpendicular is divided this whole triangle ABC into two parts, like triangle ABD and the triangle BCD. These two triangles are divided. What? This perpendicular divided the whole triangle ABC into triangle ABD and triangle BCD. So what is telling? See, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, this perpendicular drawn from the vertex of right angle to the right angle triangle on the hypotenuse, then the triangle on the both the sides of the perpendicular, the triangles both the sides of this perpendicular are similar to whole triangle. These two triangles will be similar to the whole triangle and they are similar to each other also. That means, see that here we can write the triangle here ABD. The triangle ABD is similar to triangle ABC, and the triangle BCD is also similar to triangle ABC. That means these two triangles similar to the whole triangle, they are similar to the whole triangle and to each other. That means triangle ABD is similar to triangle ABC and triangle BCD is similar to triangle ABC, and these two triangles are also similar to each other. That means the triangle ABD is similar to triangle BCD. These three things will be happens when we draw a perpendicular from right angle to the hypotenuse of a right angle triangle. The two triangles will be similar to the whole triangle and they are similar to each other also. Now here the theorem number 8.8. This theorem is very familiar theorem for you as you people are learning from your 8th class. That is Pythagoras Theorem. It's also known as namely Baudhayana Theorem. So we learn what is Pythagoras Theorem. So here the Pythagoras Theorem. In a right triangle, that means in a right angle triangle, the square of the length of the hypotenuse, the square of length of the hypotenuse. Suppose this square the length of the hypotenuse. What is hypotenuse? This is hypotenuse. We know what is hypotenuse actually. The quite opposite of 90 degrees side is known as a hypotenuse. 90 degrees opposite side is known as hypotenuse in the right angle triangle. then these two are the other two sides. These two are the side. See, the square of the length of the hypotenuse is equal to sum of the squares of the length of other two sides. The square of the hypotenuse, this the hypotenuse is AC. The square of the hypotenuse is AC square equal to here sum of the, so he said sum of the squares of length of other two sides. So the other two sides are AB and BC. AB and BC. The sum we got it the other two sides, but their squares also we require. Yes. The square of the hypotenuse. The square of the hypotenuse equal to sum of the squares of other two sides. That is what's Pythagoras theorem. So here the length of the hypotenuse, the length of the square of a hypotenuse is always equal to, the length of square of the hypotenuse is always equal to sum of the squares, length of other two sides. This is what the Pythagoras theorem. So you just remember this Pythagoras theorem. Now we go for the converse of Pythagoras theorem. And here the theorem number 8.9, and this is the last theorem in this chapter. Here let us go for in triangle. Take one triangle. Is square of the length of one side is equal to sum of the squares of the length of the other two sides, then the angle opposite to the first side is right angle, and the triangle is say a right angle triangle. Simple. Suppose it is a triangle. I know which type of triangle I have drawn here. So just imagine it is a triangle, and see that if in this triangle, if the square of the length of the one side is square of the, here I have made it a square of the length of one side, if it is equal to sum of the squares length of other two sides. So it says that Pythagoras theorem. It says that Pythagoras theorem, sum of the square of the length of one side is equal to sum of the length of the squares of other two sides, hence it is a Pythagoras theorem. See, in a triangle, if a square of the length of one side is equal to sum of the squares of these two sides, other two sides, then the angle opposite to the first side. The first side what we have taken? AC square. The angle opposite to this is this. Angle B. The angle opposite to the first side. The opposite side to the AC. The opposite angle to the side AC is equal to angle B. The angle opposite to the first side is a right angle. That means this angle B is 90 degrees, as this triangle will be known as a right angle triangle, because one of the angle in this triangle is a 90 degrees, hence it is considered as a right angle triangle. Very simple. In a triangle, if the square of the length of the one side is equal to sum of the length of the squares of other two sides, then the angle which is opposite to the first side is a right angle, and the triangle is known as a right angle triangle. So this is based on the Pythagoras theorem only. This theorems will be addressed. Now we can go for the question number 1. Now this is the first question of the 8.4 exercise. Let us see that. Prove that the sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. Very simple. Here the RTP we need to put. So here sum of the squares of the sides of a rhombus. What are the sides of this rhombus? Here ABCD is a rhombus, and here AC and BD are the two diagonals of this rhombus ABCD, are perpendicular bisector in each other. Perpendicular bisect in the sense they are exactly intersecting each other at half of their total length and also at the angle of 90 degrees. Perpendicular and also bisecting. That means a AC divided into two equal parts AO and OC. A BD also divided into two equal parts such that BO is equal to OD. Okay, they are perpendicular bisector each other at O. They are intersecting at O. What? AC and BD are the two diagonals are perpendicular bisector each other at O of a rhombus ABCD. What we have to prove that in this? See, the sum of the squares of the sides. The sum of the squares of the sides. Here what are the sides? AB, BC, CD and DA. The sum of the sides and their squares. AB square, BC square, CD square and DA square. That means the sum of the sides and their squares is equal to the sum of the squares of its diagonal. Sum of the squares of its diagonal. What are the diagonals here? AC and BD. The sum of these diagonals and their squares. So AC square plus BD square. This is what we need to prove. So let us go for the proof now. In this ABCD rhombus, let us take one first this triangle. In triangle AOB, in triangle AOB, what we can say here in triangle AOB? Angle O equal to 90 degrees. So if one of the angle is 90 degrees, it is known as a right angle triangle. So the triangle AOB is a right angle triangle. By using Pythagoras theorem, what we can say by using Pythagoras theorem? The sum of the, so the square of the hypotenuse is always equal to sum of the squares of other two sides. Yes, so let us go for the square of the hypotenuse. In this hypotenuse of triangle AOB, the hypotenuse quite opposite of 90 degrees, the hypotenuse AB. So AB square equal to AO square plus OB square. AO square plus OB square. This is equation number 1. Similarly, we can write here. Similarly, here in the second triangle and third triangle and the fourth triangle. There are 4 triangles here. So what we can write similarly in triangle BOC. In triangle BOC, where angle O equal to 90 degrees, hence we can also write here BC square equal to, well, same using similarly in the same again by using Pythagoras theorem. BC square equal to OB square plus OC square. OB square plus OC square. Again, this is equation number 2. Now in triangle, again in triangle we take it now COD. In triangle COD, angle O equal to 90 degrees, where CD square equal to OC square plus OD square. This is equation number 3. Now again in triangle what is left again? DOA, where angle O equal to 90 degrees. Again DA square is equal to DA square equal to OA square plus OD square. OA square plus OD square of DA square equal to, here also we write OA. Very simple. AO or OA. This is the equation number 4. From equation number 1, 2, 3 and 4, we can write that. What we can write? See, RTP is that we have to add this all the sides like AB square, BC square, CD square and DA square. Here AB square, BC square, CD square, DA square. We need to add it, no? Let us add the LHS sides and RHS sides. What we get? Let us observe here. AB square plus BC square plus CD square plus DA square. That equal. LHS sides I have added. Now let us see the RHS sides. What are left here? OA square plus OB square. Next here, plus OB square plus OC square. Again here, plus OC square plus OD square. Here, OA square again plus OD square. So if you observe, every OA square is repeating 2 times, OB square also repeating 2 times, OC square and OD square also repeating 2 times. So let us write here 2 OA squares plus 2 OB squares will get. Here 2 OC squares are there, 2 OD squares are there. So if you take out 2 as a common factor, what will be left? OA square plus OB square plus OC square plus OD square. This will be left over. Now what we can write? See, as we know that what here OA is nothing but AC by 2, because where OA is equal to OC, these diagonals are perpendicular, bisector each other. So here OA is half of the AC, OB is half of the BD, OC is half of the AC, OD is half of the BD. That's what we have to remember. So I can write here OA equal to half of the AC and OB equal to, here directly I will write OA equal to OC equal to, OA is equal to OC equal to, OA is equal to OC equal to half of the AC, and here OB equal to OD equal to half of the BD. So these things I need to be substitute here. Let us go for that. 2 of OA square. OA square in the sense here AC by 2. Half of the AC is nothing but AC by 2, no? AC by 2. Here half of the BD is nothing but BD by 2. AC by 2 whole square, because OA square is OA value AC by 2. OA square AC by 2 whole square plus OB square, that is BD by 2 whole square, plus OC is nothing but again AC by 2, half of the AC whole square, plus here OD, that is BD by 2 whole square. Again we need to be simplify this. Okay, let's go for the simplification this side. Remember what we need to prove this. Okay, let us do that now. Here the LHS side already we got what we require. Only RHS side we need to prove it. Let us take this now. Okay, let us take this. I am going to be rub this also. Yes. Now 2 of here AC square by 2 square value is 4. AC square by 4. Let us square for numerator and denominator. BD square by 4 will get. BD square by 4 plus again AC square by again 4 plus again what you get, BD square by 4. We got this now. Let us go for 2 of here 1 AC square by 4, 1 AC square by 4, that is 2 AC square by 4 plus here 1 BD square by 4, 1 BD square by 4, 2 BD square by 4. As we can simplify these, 2 1s are 2 2s are 2 1s are 2 2s are, as we got 2 into, that is AC square by 2 plus BD square by 2. As 2 we can take out common in the denominator, or not, with 2 will multiply, this 2 will multiply this both the terms. No, let us do the same thing. 2 into AC square by 2, 2 into AC square by 2 plus this 2 into BD square by 2, and 2 and 2 get cancelled. What is left now? AC square plus BD square, AC square plus BD square. Hence we have proved that the sum of the squares of the sides of a rhombus, the sum of the squares of the rhombus is equal to sum of the squares of its diagonal. Hence fruit. Hence fruit. See the same thing we got it no? This is what. In this way we can finish this question number 1. Now this is the second question. Diagram and given that an RTP. Let us see what is second question. ABC is a right triangle at B. ABC is a right triangle. Right angle is located at B. Let D and E be any points on the sides AB and BC respectively. Prove that AE square. Prove that this AE square plus CD square. AE square plus CD square is equal to AC square plus DE square. AC square plus DE square. So, if you observe in this triangle first, now given that I have written the same that in triangle ABC, angle B equal to 90 degrees, D and E are the points on AB and BC respectively, where we need to prove it here, AE square plus CD square equal to AC square plus DE square. This is what we need to prove. Okay, now if you observe here, ABC is a right angle triangle and also ABE is also a right angle triangle. Okay, BCD is also a right angle triangle. BED is also a right angle triangle. There are 4 triangles. All triangles are right angle triangles. We can use the Pythagoras theorem in these all triangles. Okay, let us prove this very easy. So take LHS side first. Take LHS side. What is there in the LHS side? AE square plus CD square. So how will you get the AE square in this AE square? Here it is a AE. So take triangle up. Definitely there should be AE as a one of the side. In such a way we have to take a triangle. So we can take ABE. In ABE triangle, now we have to choose a triangle that in triangle ABE. In this ABE we have a side of AE. That means AE is nothing but hypotenuse because angle B equal to 90 degrees. So by using Pythagoras theorem, Pythagoras theorem, see that in triangle ABE, AE is a hypotenuse. So the square of the hypotenuse equal to sum of the squares of other two sides. So we can write AB square plus BE square. AB square plus BE square. This is equation number 1. Now we have completed AE square, we got it. Now let us go for CD square. Where you get the CD? Here the CD. In such a way you take a triangle now, that we can take a triangle now BCD. In BCD triangle. Now we will take in triangle BCD, angle B equal to again it is a 90 degrees. So it is a right angle triangle. What? BCD is a right angle triangle. So by using Pythagoras theorem again, by using Pythagoras theorem, what we can write? See now, here CD square, the square of the hypotenuse, CD square equal to DB square or BD square, BD square plus this BC square, This is equation number 2. Now see that in RTP, AE square plus CD square we require. AE square value we know and CD square value we also we know. So the both we need to add because there is a plus here. Let us add from equation number 1 plus 2 we get. Let us add the equation number 1 LHS sides AE square plus here it is in the equation number 2 LHS side, that is CD square. That equal to RHS sides, let us add it here, AB square plus BE square plus here BD square plus BC square. Now there will be small rearrangement is required here to get here AC square and DE square. Actually we require now AE square plus CD square equal to AC square plus DE square. So how do you get the AC square? Tell me, how you get the AC square? In triangle ABC, you will get AB square plus BC square. Where is the AB square here? And there is a BC square here. Let us write those numbers. Let us write these two as a together. AB square plus BC square. Now place this both will write together. See, BE square plus BD square. BD square plus BE square equal to this is BE square plus BD square equal to DE square. That is what we get. So let us have the remaining two. BE square plus BD square. Now we can write here triangle AB square plus BC square equal to here AB square plus BC square equal to AC square. AC square. In triangle ABC, angle B equal to 90 degrees however. Now the one more, BE square plus BD square. BE square plus BD square, where BE square plus BD square equal to DE square. DE square. In which triangle? In triangle BED. In triangle BED, angle B equal to 90 degrees. Simple. Now we got the value of AB square plus BC square, that is AC square. BE square plus BD square equal to DE square. Let us substitute. AE square plus CD square equal to this value is AC square, and BE square plus DE square, BD square value is DE square. Hence we got it, the same one. Hence proved. Hence proved. So in this way, very easy problem. Once have a look on this, we go for the next question. Now here the question number 3. Let us go for the question number 3 once. Prove that the 3 times the square of any side of an equilateral triangle. Prove that the 3 times square of any side of the equilateral triangle. There are 3 sides in the triangle, that too equilateral triangle. In every triangle there will be 3 sides, but in the equilateral triangle all these 3 sides are equal in the length. So that we have taken A units, A units, A units. AB, AC and BC are with the A units distance. So 3 times square of the any side, 3 times of the square of this side. Square of this side is A square. 3 times of that, 3A square. 3A square. Of an equilateral triangle is equal to 4 times the square of its altitude. The altitude and medians are both are equal in equilateral triangle. If you draw an altitude or median for the equilateral triangle, both are same only. So in only equilateral triangle. So the square of the altitude, the height of the altitude is h units. The square of this altitude is h square. 4 times of this is 4h square. This is what we have to prove it. 3a square equal to 4h square. That is 3 times the square of any side of an equilateral triangle is equal to 4 times the square of an altitude. 4 times square of its altitude. Very easy one. See that. Now in this, see this AD is a altitude and also median. Altitude and median are same in the equilateral triangle. So this BC side is divided by AD into 2 equal parts, such that where BD is equal to A by 2 and CD equal to also A by 2, because this A side is divided into 2 equal parts, A by 2 plus A by 2. Half and half will be all, that is 1. So this A units are divided A by 2 and A by 2. So where BD equal to A by 2 and CD equal to A by 2, this you remember. In triangle ABC, it is an equilateral triangle. Here AD is an altitude. The height of this altitude is h units. The side of the equatorial triangle is a units. And this is what we need to prove, that 3 times the square of any side of an equatorial triangle is equal to 4 times of the square of its altitude. That is 3a square equal to 4h square. This is what we need to prove it. In triangle, you take any triangle. Either you take ABD triangle or not ACD triangle. You take any triangle, children. Okay. Only one triangle is necessary. I will take in triangle ABD, where angle D equal to 90 degrees. We know that because its altitude makes a 90 degrees. Okay. So in triangle ABD, one of the angle is 90 degrees. So it is a right angle triangle. So we can use Pythagoras theorem by using Pythagoras theorem. By using Pythagoras theorem, what you can write? See here in ABD triangle, at angle D 90 degrees. So AB is a hypotenuse, square of the hypotenuse, that is AB square. The square of the hypotenuse AB square equal to sum of the squares of other two sides. That means BD square plus AD square. BD square plus AD square. Now let us substitute that. AB equal to what? A units. So here A square, BD, where BD equal to what? As I told you, here AD divided this BC into two equal parts. So where BC is a units, then where BD and CD will be equal to A by 2 and A by 2 units. So where BD equal to A by 2 whole square plus AD. AD is nothing but a altitude in this figure, that is h units. So h square. Now let us make it square. Here it is a square equal to, this square is for numerator and denominator. No, let us write here a square by 2 square value is 4 plus here it is a h square. Now what we have to do it? Simple thing. This a square by 4 will transfer this side. A square by 4 will transfer this side. So already here there is a one a square. Here plus a square by 4 become minus a square by 4, that equal to h square. This a square will write as a square by 1 to take the cross multiplication or not LCM here. So what we get here? 1 into 4 is 4. 4 into a square, 4a square minus 1 into a square is 1a square, that equal to h square. See, this 4 is dividing here to transfer the other side, that become a multiplication. 4a square minus 1a square. 4a square minus 1a square is 3a square. 3a square equal to, here 4 is multiplied here. So 4 into h square, that is 4h square. Yes, now here we got it. 3 times the square of any side of an equatorial triangle is equal to 4 times of the square of its altitude. So hence, very simple problem once you observe it. Only take ABD triangle or ACD triangle, use the Pythagoras theorem, you will get answer. Here the question number 4 now. Let us see the question number 4. What is the question number 4? See, in triangle PQR, in PQR is a triangle right angle at P and M is a point on QR. M is a point on QR. M is a point on QR such that PM is perpendicular to the QR. Suppose you draw a triangle PQR, but P you write it right angle. P you have to locate it right angle, and Q and R you can locate the Q here or here. Where Q and R will comes in the rest of two vertices. So it is a triangle PQR where angle P equal to 90 degrees. M is a point on QR, and such that here PM is a perpendicular. This PM is a perpendicular on QR. So what we need to prove is, see that this PM square is equal to QM into MR. QM into MR. This is what we need to prove. So very simple that. So for this we need to be remember one theorem, that is theorem number 8.7. Already we have discussed the beginning of this video, that is theorem number 8.7. What is the theorem number 8.7? If a perpendicular drawn from the right angle of a right triangle to the hypotenuse, then the two triangles, both the sides of perpendicular are similar and similar to the whole triangle also. So here, if a perpendicular drawn from the right angle of a right angle triangle PQR to the hypotenuse, then the triangles which are both the sides of this perpendicular similar to the whole triangle and they are similar to the each other. So here, by using theorem, what's the theorem? You write here the complete theorem. If I write, it takes a long time. The same theorem here, theorem number 8.7. Write the theorem number 8.7, then you will get a full of marks. If you don't write this theorem completely, you will never get a full marks. So we have to write. What is the theorem number 8.7? Already I told you, I will tell you once again. If a perpendicular drawn from right angle of a right triangle to the hypotenuse, then the triangles, both the sides of this perpendicular similar to the whole triangle and to each other. They are similar to each other also. So we can write now from that condition. So these two triangles are similar to each other and these two triangles similar to whole triangle PQR also. But we will take these two triangles are similar first. But by the condition we can write the triangle PQR is similar to triangle PRM, which is similar to the triangle PQM. From this, what did you understand? From this. So the theorem tells the same thing. These two triangles are similar to each other and these two triangles similar to the whole triangle also. From the theorem, if you write the theorem, then only there is a meaning for this. If you don't write the theorem, you don't get the meaning of this. So you have to write the theorem completely. Okay. Now this is the statement. From this, now we take only from this. Let us take only these two triangles. So already we know that these two triangles, the triangle PRM, which is similar to triangle PQM. Already we said that these two triangles are similar. If these two triangles are similar, if two triangles are similar, then their corresponding sides are in same proportion. Okay, their corresponding sides will be in the same proportion. That is what we have learned. If two triangles are similar, then the corresponding sides will be in the same proportion. So let us write what are the corresponding sides. Very simple. I will write the corresponding sides. You will see now. Here PM. This triangle. First we will take a PRM triangle, then PQM triangle. First triangle and second triangle. Here PM is a corresponding side. PM corresponding side is QM. That equal to next to here of this triangle will take here MR. MR corresponding sides will be PM of this triangle. That equal to next to the PR. The corresponding side will be PQ. These are the corresponding sides. How did I write? Very simple way. Remember this and we can write that. I will tell you what is the trick I have used. There are the corresponding sides, I know. So if you don't understand what are the corresponding sides in these two triangles, if you get the what are the corresponding sides, if you don't write this is in the sequence, then you will get a wrong answer also. I will tell you first PM square. PM square in the sense PM into PM. No? First we will write PM here. By this QM you will transfer this side. PM by QM. We will get QM you will transfer this side. What is that? See this I will write here. Pm into Pm, that is Pm square, that equal to Qm into Mr. This is what? No. This Qm you transfer this side, this Pm you transfer this side. What will be left? Pm by Qm is equal to Mr by Pm. This is what? Pm by Qm is equal to Mr by Pm. So, this Pm by Qm is equal to Mr by Pm. Then the rest of two sides are Pr by Pq. ఈ ట్రయాంగిల్లో ఈ టూ సైడ్స్ అయిపోయాయి, ఈ ట్రయాంగిల్లో ఈ టూ సైడ్స్ అయిపోయాయి. మిగిలిన సైడ్స్ ఏంటి అంటే Pr by Pq. That is what I have written last. Very simple. From that I require only these two. These two we require to prove the RT. So I write here Pm by Qm is equal to Mr by Pm. By doing cross multiplication, Pm into Pm is equal to Qm into Mr. Qm into Mr. This Qm into Mr. This two and this two I have multiplied. So Pm into Pm, that is Pm square equal to, here Qm into Mr is Qm into Mr. You got it now? Hence proved. This is what? Very simple. So if you remember this RTP, we can do it very simply. Now we go for the question number 5. The same theorem number 8.7 we are going to be used in this question number 5. First of all, let me read the question. That the question is here. See, ABD is a triangle, right angle at A, where AC is perpendicular to the BD. Here ABD is a right angle triangle where right angle is located at A, that is 90 degrees. And here AC is a perpendicular on this right angle triangle hypotenuse. Here AC is a perpendicular on the hypotenuse. So see, if a perpendicular drawn on the hypotenuse from right angle of a right angle triangle, then the two triangles, both the sides of this perpendicular are similar to the whole triangle and they are similar to each other also. That is what 8.7 theorems will explain us. So by using the theorem, the same thing here, the given that here the RTP is 3 proofs, we have to prove it, and this is the theorem we are going to be using. If a perpendicular drawn from the vertex of a right angle triangle to the hypotenuse, then the triangles on both the sides are perpendicular. These two triangles on both the sides are perpendicular are similar to the whole triangle and they are similar to each other. By this theorem we can write now here the triangle ABD is similar to the triangle ABD is similar to triangle ABC. Triangle ABC, which is also similar to triangle ADC. The triangle is similar to ADC. So these all triangles are similar to each other. This is equation number 1 from the theorem. Now what we need, we have to go for the proofs. Now the proof number 1. First, in the first proof, see that in the first proof, which two triangles we have to take it to prove this. Already I told you how to make this. Okay, very simple. AB by BC, BD by AB. Finished. Here AC by BC, DC by AC, the perfect corresponding sides. So first of all, we have to select the triangles. Which triangles we have to take? See that here AB side is taken first. AB side, the complete side of ABD triangle, AB side and BC side and BD side. See, AB side and BD side, these two sides of a triangle ABD. So in triangle, this triangle ABD, which is already similar to, now the next triangle we have to take this. this ABD triangle and ABC triangle. Why ABC? Because BC also there here. AB and BD are the sides of triangle ABD. So I have taken ABD triangle, and here BC is a side of only this ABC triangle. So a triangle ABC. These two triangles are similar. Or not, if you don't write this theorem, we have to show that ABD triangle and ABC triangles are similar. Then you can go for their corresponding sides. If you write the theorem directly, we can write from 1. This two from 1. This we have written from 1. From 1, these two triangles are similar. If two triangles are similar, the ratio of the corresponding sides will be equal, no? If two triangles are similar, then the ratio of corresponding sides are equal. So we can write now what are the ratio of their corresponding sides of triangle ABD and triangle ABC. In ABD triangle, whole triangle, and ABC triangle, this part 1 triangle, their corresponding sides we have to choose it. It will be difficult for you and time taking process how to write the corresponding side and selecting corresponding sides. So easy way I will tell you AB is there. Right here AB, here AB, by this first one you transfer here BC, which is equal to here next one BD, by this AB square, no, one of the AB will comes here, that is AB. So these are the two. So already AB completed, BC completed here, and BD completed, AB completed. Then you get the AC by here, AC by AD, both are left. That means AD by AC you can write. The third one, if it is required, you write, or else you forget about that. Then simple. By doing cross multiplication. These two are the required things. మనకి రెండే కావాలి కనుక రెండే రాస్తున్నా. ఇంకోటి అవసరం లేదు. If you write the third one corresponding side also, that will be neglected in the next step. So need not to write. Now let us multiply AB into AB. AB into AB. That equal to here BC into BD. AB into AB, that is AB square equal to BC into BD. So we got it that. We got the proof number 1. Proof number 2 and proof number 3 also will be same only, but we have to select the triangles which two triangles are similar. ఇలా ఏ రెండు triangles similar అని ప్రూవ్ చేయాలి. ఫస్ట్ మనం చూద్దాం సైడ్ AC అంటే ఈ సైడ్ వచ్చింది. AC this side is there. And BC this side. Okay, here AC and BC and CD triangle. So you select here AC side and BC side and CD side. That means these two triangles we have to take. This triangle and this triangle. The two triangles we have to take. In this now AD, okay, then BD and CD. Okay, that will be the next triangle. This second triangle and whole triangle we have to take in the third one. Now at this time you see AC in the sense here this side. Okay, this is the common side for this both triangles. BC is a this triangle. So definitely we have to take this triangle. And DC in the sense this triangle. So AC, BC and BCK. So here BC is a side of the ABC triangle. So here the triangle ABC is similar to a triangle here DC in the sense ADC triangle ADC. So these two triangles are similar from proof number 1. From proof number 1, what is the proof number 1? This is what? From the theorem they are all similar. From the proof number 1 I can take this ADC triangle and ADC triangles are similar already. These two triangles are similar. From the proof number 1 only, here ABD triangle and ADC triangles are similar. Okay, now from this, then the corresponding sides will be in the same proportion, no? Say if two triangles are similar, if these two triangles are similar, then their corresponding sides will be same proportion. Then the corresponding sides are in same proportion. Or not, you can write the ratio of the corresponding sides are equal, or not the corresponding sides are in the same proportion. ఏ విధంగా రాసుకున్నా ఒకటే మీనింగ్ వస్తుంది. సో ఎలా రాయాలి చూడండి. ఇప్పుడు AC by the first one BC, that equal to, very simple, DC. You need not to look at the corresponding side directly, you can write here that is AC. Now we go for the cross multiplication like this, AC into AC equal to BC into DC. AC into AC, AC square equal to BC into DC. We have got the third one also. Now we go for the third one. Second one we got the answer. Now the third one. Similarly we can take now what are the triangle AD. AD ante manaku telusu. AD is a side of this ADC triangle and ABD triangle. So AD is one. BD ante ఖచ్చితంగా మనం పెద్ద ట్రయాంగిల్ తీసుకోవాలి. So triangle ABD is similar to, now let us see, and CD is a side of only ADC triangle. So this triangle we have to make the whole triangle and ADC triangle. Triangle ADC. So from one only again. This ABD triangle is also similar to ADC triangle. If the two triangles are similar, then the corresponding sides will be in the same proportion. No? If the two triangles are similar, then the ratio of corresponding sides are in the same proportion are equal. So what we can write now? AD by BD, which is equal to CD by AD. Now do the cross multiplication. AD into AD equal to BD into CD. AD into AD square equal to BD into CD. Hence proof. All these three proofs are completed. We have completed these 5 questions of the exercise number 8.4. The remaining questions we'll discuss in our next video. Till that time, keep practicing these 5 questions and 3 theorems, 8.7, 8.8 and 8.9. Thank you children. Thank you all.